Okay guys, so this is the first demonstration called the lightning show. This is where I'm going to be using the grounding sphere here, which produces a negative electric charge, and the big dome up top produces a positive electric charge. And so through the power of induction, these two electrical charges are going to want to attract to each other, and when their electric fields are close enough, it's going to have static electric discharge in the form of a lightning bolt. Anna, please don't do that, okay? All right. Here we go. 3, 2, 1. When I get closer, the electric charge becomes stronger. So you can hear that discharge is happening really fast. The further away it goes, the weaker it gets. The stronger it gets. And then we get really strong the closer it gets. All right, so for demonstration number 2, which is hair-raising science, we're using my lab assistant today.
And it's me.
What's your name?
Anna.
And it's my daughter, Anna, here to help us today. Just a quick FYI, I would never put my darling daughter in any kind of danger, so this is just for fun, right? So she is going to put her hand on the Van de Graaff generator up there, and what that does is it's going to produce electric charge transfer through conduction. So she's touching it, and that charge, the positive charge that comes out of the top of the Van de Graaff generator, is going to flow from the Van de Graaff dome into her body, and because it's positively charged, it wants to flow outward in every direction, which is why her hair is going to go crazy, and it's going to start standing up on end. So, all right, Anna, put your hand on the Van de Graaff generator. We're going to turn it on over here, and we're going to watch what happens to your head of hair. Here, look at me. Here it goes, starting to get big.
Let's do this.
All right, stop moving your head. Just leave it still. There you go.
Can we stop it?
Yes, that's what I'm going to do right now.
Ow.
There we go.
See that?
What?
See that?
Now it's all down in front of your face. Okay guys, so this is demonstration number 3, electric bubbles. I'm going to use this bubble machine right here, and what I'm going to do is I'm going to start blowing the bubbles towards the Van de Graaff generator, first without it being on so you guys can see how bubbles will be all around it, and then once I have Anna turn on the Van de Graaff generator, you'll see what happens once the Van de Graaff generator turns on, how those bubbles are going to react. So first we'll do this without the Van de Graaff generator being on, so you can just kind of see they just float all around the Van de Graaff generator. Okay, Anna, now you can turn it on. Now you can see anywhere I put the bubbles, they're being repelled by the Van de Graaff generator. Now you can turn it off. Okay guys, this is demonstration number 4. This is called foiled again. These are aluminum cupcake tin liners. So it's made of aluminum on the outside, which means they're good conductors. And we're going to find out what their charge is in just 1 second. We know that the charge charge that's coming out of the top part of the dome here of the Van de Graaff generator is a positive charge. So how this reacts is going to tell us what the charge is of the aluminum cupcake liners. So I'm going to start it in 3, 2, 1. And they were repelled. So what does that tell us about the cupcake liners? You have to use your brains for that one. Alright guys, this is the last demonstration for the Van de Graaff generator. This is demo number 5, Snap, Crackle, Pop. This is where I have some Rice Krispies in the styrofoam tray up on the top of the Van de Graaff generator, and it's just stuck on with a little bit of tape up on the top. But I'm going to start the Van de Graaff generator, and you guys can see what is going to happen with the Rice Krispies when I turn it on. Here we go. 3, 2, 1, and it's raining Rice Krispies in here. Ah! Even after I turned it off, there was still some residual static electricity. Even my hair is still attached as attracted to the Van de Graaff generator, you can see.